So for the assignment I just gave you, that assignment's due a week from today, which I think will be plenty of time. Actually, I think that you could finish everything on this assignment after today's class. You'll have the know-how for all of it. So we'll be back to twice a week classes. You know, we will be meeting on Thursday as well, just kind of a one-time thing. Any questions related to the announcements before we move into the new material for today? All right. You know how last time I suggested that you should take notes? I think that in today's class it's going to also be really important for you to know the syntax of the commands that you're going to be seeing. And so I printed out some of the slides, although not all of them. And after I printed, I realized, man, the font is awfully small on some of these. So I think in some cases the handout will be helpful, but in other cases you may need to supplement what's on the page here with some notes of your own. All right. So if you haven't already, why don't you go ahead and start up Matlab. We're going to be using it again today. So does everybody have a copy of the assignment and the notes? All right. Just as a little bit of a refresher, remember that a 1D array means if we were going to think about it in terms of a spreadsheet, it would be one row, but it could be many different columns. And so the array can have as many values as we need it to have. That's also known as vectors. And we also talked a little bit how to generate plots in Matlab, but we didn't do anything with customizing how that plot looked. Just by default, it was a thin blue line that was interconnected. But sometimes we want to see the data points themselves rather than just a connected dot. Sometimes we want to have more control over the thickness of the lines and so on. So that's what we're going to be doing today, is delving into those options. So just as a little bit of a refresher, let's create a couple of variables today. Let's start by creating an array x equals -5 to 5. And remember that the default here, when you're not specifying the step distance between the values, is for it to be 1. And then once you've created that array, create a new variable of y, and that would be x squared. So if you're not sure how to move forward, you can follow what I'm doing on the screen here. Starting off with x equals brackets -5 to 5. Now, you'll remember that in the past, sometimes we suppressed the echo, but in this case I'm suggesting that we shouldn't suppress the echo just because we want to see what is that array. And so you can see it goes from -5 to 5. And so these are all of the values that are stored in the array. And as another bit of a refresher, remember that here in the workspace, if you double-click on a variable, then it will bring that up in a tabular format that is kind of familiar and looks a little bit like what we were used to in Excel. So that if we wanted to edit that, we could do it here in this variable editor. We could change the values as needed. We're not going to do that, though. Let's close that editor. So we have our variable as assigned. All right, now what do you get if you do the function y equals x squared? Get an error message, yeah. So the reason for that error message is that Matlab doesn't know how to square an array unless we give it kind of a little bit more information. So the function for that is dot and then squared. And that is the power function for a matrix. Because remember that this variable isn't just one number. X isn't just a single number. If it was, then we could do x squared. But when we have an array of numbers, then the way that it executes the math is a little bit differently. And so the dot operator allows us to do things like squared. And so now we can go in here, and instead of just doing, that's convenient. All right, so instead of doing y equals x squared, we can do y equals x dot squared. Okay, and now if you look at what it did, our previous array was -5, -4, -3, and then that was x. And so y, which is x squared, each one of the values has been squared. So the -5 is now 25. -4 is now 16. 4 is now 16. 5 is now 25. Because each one of those values inside the array has been squared. Let's see if we can get PowerPoint back. All right, so there's other functions besides just the squared that we need to use that dot operator with. You also need to do it if you're going to multiply a matrix or divide a matrix. So let's get a feel for that. You just squared your matrix, so now let's try multiplying it by some number. So for instance, we could say y equals x, and if we want to multiply it by 2, we'd have to do dot multiply by 2. And so our original x, if I call that out just to refresh our memory, what was x? X is -5, -4, -3, and so on. And so if we multiply that by 2, each term in the array is now double what it was before. The same thing if we wanted to divide. So if we wanted to say y equals x dot divide by 2, now y has half for each of the values inside of the array, half of what it was for x. Okay, so that's just another tool that you have if you need to do operations to an array of multiple numbers that are just, larger than a single variable. Any questions about that? Okay, well, what if we are going to try multiplying two vectors together? Well, try this. Create an array with A and with B, and even if you do the dot operator, you're still going to get an error message here because the matrix dimensions aren't the same size, meaning that we would have to have a 1 by 4 for A and for B to be able to multiply it together. Okay, so let's see if we can get that same error message that is on the screen there. So A equals 1, 2, 3, 4. Okay, suppress the echo. B is 5, 6, 7. Suppress the echo. And if we do A dot multiply with B, get the error message there. But I think that if we say that B is 5, 6, 7, 8, then we maybe would be able to multiply the two together. Yeah. So in that case, 1 times 5 is 5, 2 times 6 is 12, 3 times 7 is 21, 4 times 8 is 32. So it wouldn't be able to complete that matrix multiplication if each one of the terms in A didn't also have a corresponding term in B to multiply with. Now we don't have to do the dot operators if we're applying a built-in function, like the built-in functions that Matlab has cosine, for instance. So we could do cosine of A, and even though A has more than one value, it'll execute its built-in function to each one of the values inside of that array. So it finds the cosine of each term inside the array. All right. So last time we did some plots, and they didn't look great. They were pretty boring. We can do a lot more in Excel than what we looked at last time. So let's create an array that we're going to use for purposes of plotting. So define x as from -5 to 5 in steps of 0.1. So that's going to be lots of numbers there. You do want to suppress that with the semicolon. If you don't suppress it, then you're just going to get a page full of data. And then let's create y to be the square of each term in x, and then plot that, just to refresh our memory on how by default the plots appear. Now, I don't know how many of you are using MU Remote to access Matlab, but when I do, sometimes I get an error message the first time I create a plot. Something about the graphics driver isn't happy with what I'm trying to accomplish, but you dismiss the error message and eventually it'll bring up the plot, albeit maybe a little bit slower than it otherwise would. So it still works even if you're doing MU Remote. So here's that plot that it created. Okay, interesting. I think that corresponds to what we'd expect. Here we're going from -5 to 5, and if we're squaring it, that means that the extents are going to be from 0 to 25 on the y-axis. Now, I haven't done it before, but let's try this. Plot yx. And now it's plotting it sideways. And so what that means is x doesn't necessarily just mean the horizontal axis, like in our mind it always does. Remember, x is some variable assignment to an array. But the way that the syntax of the plot command works is plot and then the parentheses, and whatever is in that first field is the variable that's going to be plotted along the horizontal axis. So what we're doing right now in this plot that's on the screen is on the horizontal axis are the y values, and on the vertical axis are the x values. Hopefully that doesn't blow your mind. But I just wanted to point out that plot xy doesn't mean plot the x values on the x-axis necessarily. It's more of what comes in the first space before the comma and then what comes in the second space after the comma. So I'm going to go back to plot xy, back to normal. By the way, when I do that, you'll notice that the existing graph is going to go away. So you can save the plot before you overwrite it. There is a way to hold it so that you can draw new things without erasing what you've already done. I'll show you that a little bit later today. But then the other thing to keep in mind is that you can always highlight commands from earlier in your history and repeat them. So you could Control-C and then Control-V to paste. So we'll do all of that today. All right, so we've got some boring plot here that we want to spice up a little bit. What we don't like about this plot, lots of things. It doesn't have axis labels. There's no chart title, no legend. It's not actually showing our data points. It's just showing the curve. And sometimes you need to see the actual data points. Sometimes a curve is maybe a little bit misleading and the data shouldn't be connected. So we're going to look at all of the options available to us to change the way that plots look. The general format for that is plot xy, and then after that second comma, we can have a lot of different commands that make changes to the color, the line width, the line size, the dashing symbols, symbol size, symbol color, and so on. And there can be a lot of them stacked in there. And so a line specifier isn't actually the command that you do. I'll show you the actual commands that you use. So just to show you the first instance of that, try this. Plot x, y, and then inside of a single quotation mark, the dash dash. And what that should give us is a plot that is dashed, right? All right. Having a hard time. I wish I had a bigger screen. So here, plot x, y, and then in a single parentheses, dash, dash, close parenthesis, close quotation, and parentheses. So then it changes it from a solid, which is the default, to a dashed line. So dash, dash isn't the only option that's available to us. There's lots of other ones as well. So this is where you may need to supplement what's on that handout I gave you, because I think this is probably pretty hard to see. If you do the colon, then that would give you a dotted line, or dash dot would alternate between dashes and dots. And you can try those. We're not in any particular rush today. I'm going to try the dash dot just to illustrate. So we could do plot x, y, and then dash dot. And as far as the order of these commands, it's pretty forgiving. So here it's changed it. I think that if we do x, y, and dot dash, it's still going to be cooperative. I'm not sure about that, but let's see. Yeah. Looks a little bit different, doesn't it? Okay, so that's just related to the line, and it's not necessarily showing where the data is yet, though. Remember that our data was in increments of 0.1, and so there may be more than the spacing of every 0.1, or there may be less, just depending on the space that it's plotting in. Okay, we can also put in markers. And the O symbol is an indicator that you want to have markers. So try this. The dash dash is going to tell it it's a dashed line, and then the O is telling it to include markers. And we're combining those together. So plot x, y, and then dash dash because we want a dashed line, and then the O for circle markers. And the plot it comes up with looks like this. And there's lots of different spaces. I didn't get a chance to try it. I want to try the pentagram. I think that'd be pretty exciting to see it. So plot x, y, dash dash p for the pentagram. Oh. All right, there they are. Okay, cool. Triangles, upward pointing triangles, diamonds, squares. So if you have many different data series, like if you have several different groups of data being displayed on the same plot, then it may be increasingly important to differentiate between which data points belong to which series using these markers. I got to try one more. A downward pointing triangle, letter V. Okay. And by the way, we don't necessarily even have to have the line, I don't think. Let's try plot x, y, and then plot x, y, and then just the downward facing triangle. Okay, those are the data points, and there's no connecting line. Any questions about the markers? Okay, we can change the color of our lines. So as you might expect, R is going to give us a red line. If that's the only other tag that we give it, it assumes that it should be a solid line. First of all, it assumes that there should be a line. And since we haven't told it anything about markers, there's no marker. And the only tag that's here after what to plot is a change of color. And so it applies that change of color to the default thing, which is a single line with no markers. And there's other colors as well. I'm not sure how a white line would work out. Maybe there's probably another command to change the background color. Okay, so what if I want to do plot x, y, and with a red line? So it creates my red line. Plot x, y with green. Yep. Let's try that white one. Yes, that's a helpful plot, right? All right, we won't do white. Okay, so that's how we can change the colors of the lines. All right, so we can jam it all together with lots of different options. And you can change the color of the line. You can tell it to add the markers. And then you can change the width of lines, the marker size, edge color, and so meaning the outline of the marker and the shading of the inside of a marker. And so here's an illustration of a plot that's going to use some of these options all at once. So let's do this one. Okay, so plot x, y. So the MO is going to make the line magenta. Okay, so first of all, dash means a dashed line. M is magenta dashed line. And then O is that our symbol for each of the data points should be a circle. So that's what I've specified thus far. Okay, next I'm going to give it another command that I want to specify a different than default line width, because the default line is awfully thin. So let's do line width, and then it needs to know what number for the line width, and so 2. If I wanted to, I could close that now. So let's just try where we're at so far. So this is where we're at so far, and I can keep making refinements to it. And so rather than typing all that in again, I'm going to highlight this, and I'm going to do Control-C, and then I'm going to do Control-V. All right, so I was at line width of 2. I can put in another comma, and now I want to specify some other aspect. And it can be in any order. It's not like I always have to specify the line width before the marker size. I can switch the order of these tags in any way that I like, any way that I think of. Marker size, let's say that we want nice big markers. They should be size 12. And marker edge color, so that is the outside border of whatever the marker is, and that should be green. And then finally the marker face color, I want to be yellow. Oop, almost didn't do the... All right, let me maximize that so we can see it all at once. Now, right now the markers are so big that we can't even hardly see that magenta line. Does everybody's look like this, basically? One little typing error can throw the whole thing off, right? Programming is unforgiving. So let's change that. Let's say I don't like this plot. The markers are too big. So I'm going to copy this. Control-C to copy. Control-V to paste. And then I'm going to change the marker size. Instead of 12, maybe try 6 instead. Okay. Pull this up. That seems like an improvement. I can see some of that magenta line, but still it's maybe not quite right yet. So I'm going to paste again, change that to 4, and I'm going to make the line even bigger. Line width 3. See how that looks. So you have flexibility over how things look. Any questions so far? By the way, don't worry. If you're not a command line enthusiast, like if you don't love typing all these little specifications, there is a way to manually change our plot, and I'll be showing you that today. But the advantage of this command line approach is, let's say that you need to do 100 plots, and you want them to all look the same. This is a great way to batch create plots that all look the same. Whereas if you had to manually go into the properties of each plot and change the marker color, the line thickness, the dash size, and so on, that'd probably drive you crazy by the time you even got halfway through the list. So that's why we're learning this command line approach to begin with. So here was the before, here's the after. Okay, so here's some more real-world data than just that parabolic plot that we had before. Let's say that you work for a company, and here's some some historical sales data, and we want to generate a plot that'll plot that for us. And when we're finished, what we'd like the plot to have is a dashed red line with markers showing the data that are asterisks, and then use a line width of 2 points and a marker width of 12 points. Okay, so you have the handout that has the syntax. And I'm going to pause the recording and just kind of wait for a minute, because I want you to try and, on your own, figure out how to do this rather than just following the commands that I'm typing on the screen. And if you're really stumped, then eventually I will show on screen how to do this one. But I'm just going to give you the suggestion to begin with. Let's call the array of the year data, maybe you could just call that Y. And the array that has the sales data, maybe that could just be S. And then we want to create a plot of that sales data. I like to build mine in steps, one command at a time, just to make sure that each tag I'm adding is having the intended effect. Okay, so a dashed red line with asterisk markers, line width of 2 points, and marker width of 12. So I think this is what it should look like, right? Everybody get to this point? Let me bring back up. So let's review the command here. So plot YS tells it on the horizontal axis plot the Y data, and the Y data is the years where it's going from 1988 to 1994. Was anybody here alive in 1988 besides me? None of you guys remember 1988? Oh, you're missing out. It was an awesome year. It's an awesome year. Oh, the Berlin Wall fell, I think, in 89. So the year before, 88, Seoul Olympics. I remember watching the Seoul Korea Olympics in 88. Good Olympics. All right. All right, so that was our Y range, and S is the sales. So that's going to be on the vertical axis, the S. Okay, now, I made the mistake earlier. I forgot to put in the single quotation marks. And those have to be there when you are specifying the options such as the dashed line, asterisk, markers, the red color. So I didn't specify any different marker color. So right now, the marker is red and the line is red, because I changed both of them in this tag. But from before, we learned how to change marker colors to be different if we wanted to do like a black marker edge and face color. So I could do all of this from before, which I guess if you push the up arrow, it gives you your previous one. I can go in and add some more commands here. So I could do marker, edge color, and I'm guessing B is probably black, right? B is blue. K is black. All right, so I want it to be color K. And then I'll also do the marker face color of black, which is K. Let's see what that does. My plot's back here. Okay, great. That looks real nice. Everybody with me? I don't necessarily care if you get those markers black, but you can if you like. Okay. You can use the same command to plot multiple data sets in the same window. So that if we had another array, then we could put both lines on the same plot at the same time in a single command. And we'll do that a little bit later today. We'll come back to this slide and add another column of sales data. And so if you wanted to create a plot with, you know, one company's sales data and then another company's sales data, the format that would follow would be you'd have your horizontal axis data in X, and so remember for our horizontal axis that was the years, and so we'd have like year, and then what we'd have is the vertical axis, which is some amount like S, and then if we wanted to have another one graphed, this A is going to be the numbers you want to display on the horizontal axis for the second series. And so maybe you'd be just calling back to the year again and then have the second vertical axis series for the next one. So you can have multiple data sets on the same screen at once. And you can add separate specifiers. Like you can have one of your data sets be blue, another one be red, you can have green markers for the next, and so on. As long as it needs to be, you can add the tags to each data set separately. Now this mentions the hold command. Remember earlier I showed you that every time we tell it to plot, it erases what the old plot was. The hold command will disable that so that the changes you make appear on top of the previous plot. And so it's a nice way of constructing the plot the way that you like it bit by bit, is by holding what you have, and then you can turn the hold off later. Okay, so here are some more formatting options, and I just need to mention that these should be executed after you've created a plot. These operations won't erase your plot. Even if you haven't done the hold yet, these are still going to be drawn on top of your existing plot. So what we have so far in our plot of this one, it looks nice and colorful, but it doesn't yet have any axis labels, vertical or horizontal. It doesn't have a title. It doesn't have some text that we could add. So let's use some of those commands. First of all, what do you think would be a good X label? Years. All right, so let's do that. X label, and so our syntax here is X label, parentheses, single quotation mark, years. Okay, I close that. Now I'm going to bring up this off to the side so that you can see when I execute that by pressing enter, now it's just added years. It didn't erase what we had before. And so we can do the same thing with a Y label, and maybe, oops, Y label. This one could be sales, I suppose. Sales in millions, because that's what it was saying in the here in our original data. It said these are amounts in millions. So if I do that one, now it says sales, and then the units of sales are in parentheses there. Dollars and millions is the units of the sale. And those parentheses inside of parentheses can sometimes be confusing, but since it was inside of the string, inside of that single quotation mark, then it interprets whatever you put in there is going to be in the label. Okay, what were some of these other ones? We also could do a title. Okay, so title, sales data over time. Okay, and we'll watch that magically appear up at the top. Okay. Now text in some XY location. Now this one took me a little bit of time to figure out, text XY, because I was thinking like, well, how many pixels wide is this figure? How many pixels tall is it? Like if you want to put text in a certain location, at first I was doing, like, I thought, okay, I want the text down here at the bottom, so I said 0, 0. But actually I was overthinking it. The location is just the coordinates that you've already defined. And so let's say this was a bad year, right? 1992 was a bad year for sales. And so we could do this one, text. And if we want that to be explaining this bad year, the X would be 1992, the Y would be 18. That's where we're going to put the data label. And then you just put whatever label you want it to be there. A bad year. All right. So it's kind of right on top of it. So maybe I would put it below. 1992, 17, a bad year. Now the problem is that the old one is still there. I think we might be able to use this cursor, select the old one. No, it's not that easy. Well, we could always just plot it from scratch, right? Because we've got all of these. Okay. If you just copy and paste all of these, now I'm going to get this error message in here, but that's all right. So I just created my whole graph from scratch just by copying and pasting all that from before. And now I'm going to do that. Okay, I need to get my Y label and the title. Let's see, where was my, up here, my Y label and title. So here's the Y label and title. Control C, execute that again. There they are. And then I can put that text that I wanted a little bit lower than the marker itself. So now there it is, right below the marker, a bad year. I really like that you can do your whole graph over, your whole plot over again just with a copy and paste. I think that's potentially very useful. We can also put in a legend. Now right now there's only one series. So the array that we're plotting is the years versus the sales. And there's just one series of data. And so here it's showing you the format would be legend and then label 1, label 2, label 3. If there were multiple series, then you need to do that. But for us, there's only one. And so we could do legend. And the legend that we do here is maybe company performance. Let's see what that did. Here's our legend that was created. Now, if we had multiple companies, we could have IBM as one of the labels, Apple for another label if it was like stock performance or sales for comparing different companies. Okay, we can change the bounds of the plot. Like right now, what are the bounds of the plot that we've got? It's starting at 88 and it's going to 94. Well, what if we didn't like how that marker is right on the edge? So if we wanted to change the bounds of the plot so that it started at 7 vertically and at 1987 horizontally, then we can specify the bounds using this format, axis, and then you give it the x minimum, the x maximum, the y minimum, and y maximum. And you need to have brackets around it. And so it should say axis, parentheses, brackets. All right, so now we want to change it so that the horizontal is inclusive of 1987. So I'm going to say 1987 is my x minimum. And my x maximum, maybe I want it to go to 1995. And now the y minimum, I want it to be 7. And then the y maximum, I suppose 28 is fine. All right. Oh, I forgot the end brackets. Yes, it's saying, did you mean to put in that bracket there? Yes, I did. Thank you. All right, so it regraphed it, and now I've got a little bit more white space off to the left of my first data point and below my first data point, a little bit extra white space. Okay, so that's changing the axis range. Try some of these other functions as well. Axis equal, then try axis square, axis type. See what happens when you execute each of those operations. The grid on, grid off, wax on, wax off. Okay, so I'm going to try axis equal. So axis equal, if you've got, it will give you the same number of units on the horizontal as you have on the vertical. So it's an equal number of units there. Axis square. Okay. Looks fine. Axis tight. It zooms in, you know, killing that excess headroom that we had from before. Grid on, if you like grid lines. Oh, those look nice and professional. Now we've got grid lines. Grid off if we don't like it. Okay, they're gone. Any questions up to this point? All right, so here's our data from before. We've already made the changes that we like. You know, we gave it an x-axis label, a y-axis label. We gave it a title. We played around with the axis limits. We turned the grid on. So we don't need to do that now. We've already been playing with it as we went through. Another thing that you can do is you could copy the figure that it's created. Over here is our figure tool, and so if you do edit, copy figure, it's put it in the clipboard. So now I could start up Microsoft Word. Let's say you're making a report of some sort, and then you can just paste, and there's the figure. And if needed, you can you know, crop, change the width as desired. And it scales nicely. It still looks pretty sharp even if we zoom in. Oops. So it's doing this as not as a bitmap, but as actual, well, maybe it is a bitmap, but it's a nice sharp one. Okay, so that's how you can paste the figure into a report. Just edit, copy figure. I suppose you can also save, and I never clicked on this, but it gives you many different options, you know, PDF, JPEG, TIFF, and so on. So all of the standard format types. Now, a lot of the stuff that we've been doing on the command line, like changing the properties of our figure, we could do in the tools that are provided for the figure itself. So here, for example, here's our plot. We could do edit axis properties. So if you edit the axis properties, now it's saying here's the limits, the x limits. So we could remember how when we did it on the command line, but we could do 1987 that way, and it immediately makes the change to 1995. And we could change the label. Instead of years, we could say year. So the way to get to that again is edit axis properties. You could change any of the things that we've been doing before through these axis properties. There's also the figure properties where you have the, you can change the colors. So if you click on one of these axis markers, for example, you see how it's the asterisk right now, where it says here marker asterisk. We could change that to the beloved pentagram, I don't know, hexagram, whatever. Change the line marker widths as needed. So those are here in the edit. Okay. Okay, we talked about the hold and how you use hold to prevent from overwriting what you've already done on the graph till now. So hold on means that you can plot another one on top of what's already there, and hold off will disable that. So just to illustrate, oops. I wonder if I still have my from before, yeah, X and Y. Well, X. I don't remember what's in X. All right, so there's X. Let's do M equals X squared. So we have to do dot, okay, X dot squared. All right, so now we can plot M versus X, and then try hold on. Okay, and then if we plot now X versus M, then it's going to plot both of them without erasing the one from before. So now we can hold off, and if we do plot of X versus M, then it's just going to be the latter one. So that's just an illustration of how the hold feature works. As long as hold is enabled, it's going to continue to graph all the next operations on the existing figure window. So we're going to need to hold on when we create some new data set. Now, here's our original from 1988 to 1994. We had all these amounts. Let's say that that was excavator sales, and now we also want to have another figure that includes crane sales. So let's create a new vector, y2. Oh no, why would we call that y2? Let's call it s2. That makes more sense. Because our earlier one was s, right? Excavator sales. So this next is going to be s2. It's still going to be the same number of years. Okay, so let's close that variable. Okay, so I'm going to create S2. So it's kind of small, I guess. So it's 7, 14, 25, 18, 18, 26, and 23. So we've got S, which is excavator sales. We've got S2, which is crane sales. And we've got the year. So what we want to do is create a plot that has all of this. We want to plot both of them. So I want to get my old plot back from before. And so the way I can do that is I can scroll up here and find, where were the commands where I created that nice plot that I had previously. I think maybe it's these. Control C, scroll down back here, Control V. Okay, so is that, and I want to put, okay, so it already says years. I don't have a vertical axis yet. So I'll go find where was my command where I created that vertical axis label. It was, here we had the title and the axis label. Paste that in and take a look at my plot. All right, so now this is the one from before that had only the excavator sales. Now we want to put in the crane sales as well. So here's what we're going after. It should be a black line with circle indicators. We want to have the grid lines going from 87 to 95, from 0 to 35, with a legend that describes both of those. So I'm going to pause the recording, and you need to figure out how to make it look like this. After a couple of minutes, then I'll start poking around on it and show the commands that will lead to that. got a lot of things plotted right now. How to get the marker to be bigger. Sales data. I'm going to call this close enough. It's a tedious thing to do it by the command line, at least in my opinion, since I'm so used to Excel. But on the homework assignment, you'll get a chance to practice some of these skills. I think that, there's 3 problems. Now let me give you some instructions here. It says to save each one of your scripts as an M file. And so, what we've been doing is doing it all here in the command line. And you can save it as a script. Remember the new script feature where you have it line by line. And then, once you've written the script, you can run it and it'll create the plot. So there's 3 different problems. You should create 3 different files and upload each of those 3 to MU Online. Now here's an important thing. Don't do it in 3 separate submissions. Submit all of them at the same time. The grader mentioned to me that sometimes when people have multiple files, they'll submit one of them and restart the entire assignment over again, and then it's more difficult for the grader to see that you've actually done that, and he wants to avoid overlooking some of your work. So on problem 2 and problem 3, it says to save it on your network drive. I don't care necessarily where you save it, whether it's a network drive or onto a flash drive, but the bottom line is that a week from today at 11 o'clock this is due, and those 3 files should be uploaded to MU Online. Okay, that's it for today. Let me know if you've got any questions. I'll see you on Thursday.